Good morning, all. Happy New Year to all.
Happy New Year. I hope this screen is visible to all.
Okay, so shall we start?
Yes, sir.
Right. So we were discussing about the frictional chapter, friction chapter, and in that we have solved various numerical examples. Now let us solve few more. So let us take up one new example. Here we will see this is a cylinder whose diameter is 3 meter and it weighs 400 Newton, resting on two rough inclined surfaces. So there are two inclined surfaces in this manner. The angles, they are 45 degree and 60 degree with respect to the horizontal surface. Uh, if the angle of friction is 15 degree, find the couple applied to the cylinder that will start it rotating clockwise. I will repeat, you are supposed to identify the couple applied to the cylinder that will start the cylinder rotating in the clockwise direction. Okay, so this is what is asked. We are now supposed to identify the couple value which will cause the motion of this, just start the motion of this cylinder in the clockwise direction. That means we are supposed to identify this value. Let me say capital C, which is nothing but the couple. And as per the definition of the couple, it is nothing but uh, the force which will create a twisting effect with the help of two equal and opposite directed forces, isn't it? So I can represent that couple in this direction, since it is asked in the numerical that it will be creating a clockwise type of rotation. So this arrow is representing a clockwise couple. Now there are few more things which are given, that is the self weight of the cylinder. This is 400 Newton. Okay. These are two rough surfaces. Being rough surfaces, the angle of friction is also given, and both the surfaces have got the same angle of friction. Now what you will do, you will draw the free body diagram associated to this. So you know the diameter is given as 3 meter. So radius will be how much? 1.5 meter. So this is 1.5 meter distance. This is 1.5 meter distance, correct? And there will be normal reactions at these two locations. Let me call these locations to be point A and point B. So these will be n suffix A, n suffix B. Okay? We have the information of friction resistance in the form of angle of friction, that is you can say mu value, if you want to identify mu s, it will be tan phi s. So tan 15 degree. How much does this come out to be? Tan 15 degree. We have already solved this earlier also. It comes out to be 0.268. Okay. So this forms the mu s value. Now you just have to understand the direction of the frictional resistance. That's it. But you can see uh, in the numerical it is already mentioned that you are supposed to identify a clockwise rotation. So being a clockwise rotation, this is going to move in this direction. Since it is moving in this direction, now let me know at point B, what will be the direction of frictional resistance? It is moving in the clockwise direction. So what should be the direction of uh, frictional resistance? It will be upwards. So I will represent the frictional resistance in this manner. What will be the magnitude or value of this? F max will be equal to mu s times NB. So you substitute the values 0.268 times NB. Over here, what should be the direction of frictional resistance at point A? It will be downwards. So once you know the direction of these frictional resistances, then it becomes very simple to calculate the unknown forces, isn't it? So now I'm interested in finding out this C value. Okay. So since it is a couple value, that means I am also supposed to take moment value. Correct? So let me consider this point to be point O. We will be applying all the equations of equilibrium in order to identify the unknown values. So here, as you can see, the unknown values are Na, Nb, and C. There are three unknowns. So we will have to make use of all the three equations of equilibrium. So let us start with summation of forces in x direction equal to 0. For that, what you can do is you can consider this axis system x and y, and with respect to this you can resolve the inclined forces. So by that, these will be the resolutions, correct? Okay, this will be like this, like this. So I will draw it separately in order to have clarity. Okay, I won't be drawing the complete circle and all. What I will be drawing is this information only. This point and this point over here. This is NA, NB, whatever. Okay. This is NB, and then over here, frictional resistance, and here, the frictional resistance like this. So you can resolve the and 400 Newton. This is C. This is what we need to find out. This is point O. Okay. So I will be writing down the values. You please verify and please correct me if I am wrong. Okay. So this is Na cos 45, this component, Na sin 45. Again, this will be this angle. That means if I consider, okay, this will be this angle. So Na cos 45, Na sin 45. Is this okay? Since it is 45 angle, so there is no such issue for this case. Let us verify over here. Okay. So I will write the values and b cos 30. This will be and b sin 30. This component now shall be because yeah. So this will be sorry, not n. This will be 0.268. 0.268 times. Oh, sorry, not this. My bad. This 0.268 and this will be 0.2. ये बराबर है क्या? Please, I have written these components. थोड़ा extend करता हूँ. 0.268 NA sin 45 and this is NA cos 45. This becomes 0.268 NB cos 60, 0.268 NB sin 60. Is this okay? Please let me know. Yes. Are these values okay? Because this will be 30 degree, this will be 60 degree. Am I right? Please respond. Yes. So what you do, you substitute all the values which will form this equation number 1. So the values shall be NA cos of 45, which is in the right direction, plus 0.268 NA cos 45 again in the right direction, plus 0.268 NB cos of 60 minus NB cos 30 equal to 0. Let this be equation 1. All values are unknown values. Summation of forces in y direction equal to 0. So these values NA sin 45 minus 0.268 NA sin 45, then minus 400 this value plus 0.268 NB sin 60 positive, then plus NB sin 30 equal to 0. This is equation 2. Are these values okay? Please verify. Okay. Now the next part is you have got these equations, 2 equations, and in these 2 equations you can solve these 2 equations and get the values for NA and NB. That can be done. I am getting these values for NA and NB to be 283.09, 283.09 Newton, and NB 346.5. You can verify these values. So the next part is to identify the couple value. So in order to find out couple, what we will do, we will take moment about point O. Summation of moment about point O equal to 0, since everything is in equilibrium. Therefore, it will consist of this C value Am I right? Because we are taking moment about point O, and as you can see, about point O, this couple is also acting. So I will have to incorporate that C value in the equation. Summation of moment about point O equal to 0 as well, right? The other values are, now here what do you observe? Okay, summation of moment. If we take moment about point O, and if I consider this value only, that is Na, isn't it? Na and Nb. What do you observe? Yes, what is the observation? Yes, anyone tell me? Hmm? Are you people there? Am I audible or not?
Yes, sir.
So, in this equation, can you please let me know which value is to be substituted, or what should I write in that equation further? I mean, after C, what should be written? Because if I consider only Na, so you can see if I take moment about point O based on Na, what will happen? It will pass through this point itself, point O, and your complete equation will become 0, isn't it? But somehow I need to find out the value of couple, since it has generated some motion or it has impeded the motion. So in such case, what should be done? Yes. See, we have got this thing, frictional resistance. Now, what is the position of frictional resistance? It is perpendicular to the direction of the radius, isn't it? So we can make use of this equation, or rather this frictional resistance, and with the help of that frictional resistance we can identify the value. It is as simple as that. So Na and Nb, these will be passing through point O, whereas the frictional resistances, what is the value for this frictional resistance? This is 0.268 times Na, and this is 0.268 times Nb. Okay, this is 1.5 meter, this is 1.5 meter. So when you take moment, just let me know this horizontal component with respect to this, what will be the value, in which direction it will rotate, whether it will be rotating in the clockwise direction or anti-clockwise. Please let me know. 0.268 Na into 1.5. So in which direction this is rotating about 0.2? In the anti-clockwise direction. So this will be minus. Plus, again, if I consider this component, it will be again minus 0.268 times Nb into 1.5 equal to 0. So we have already evaluated Na and Nb values. With the help of that, you substitute these values in this equation and you find out C value. I am getting C value as 253.09 Newton meter. This is what I am getting. 1 minute. Okay? Have you understood this numerical? Very simple. Over here, you are just supposed to identify the direction of frictional resistance with the help of the information which is mentioned in the numerical. That's it. It is as simple as that. Now, next. Yes. Here, in this numerical, we have got two surfaces. Both are rough surfaces. One horizontal and another one is inclined, and that inclination with respect to the horizontal surface it is 60 degree. This is given. Then there are two blocks. These two blocks, they are held in position with respect to one bar. The terminology for this is strut, S-T-R-U-T. This is a strut, S-T-R-U-T. Strut is another member which will keep in position two different rigid bodies. Right. So this thing actually uh, is something like this. Right. Connected somewhere, I mean, at the center of the block, like this. Okay, both the centers. So this is B point, this is A point. This inclination of the strut with respect to horizontal, this is given as 30 degree. Now here, block A weighs 400 Newton. This is given. Block B weighs 300 Newton. And the weight of strut AB, it is how much? It is given as 200 Newton. This is 400. This is 300 Newton. And the weight of this strut is given as 200 Newton. If the coefficient of friction is 0.25, determine the minimum coefficient under A to prevent motion. So this coefficient of friction is under B over here. It is given as 0.25. You are supposed to identify minimum coefficient below A, minimum coefficient under A to prevent motion, to prevent the movement of this complete system. Now, what is the natural tendency of this system? In which direction do you think this will move? Based on that, we need to draw the free body diagram. Yes. In which direction do you think this complete system will try to move? What will be its natural tendency? Can anyone tell? Yes, so it will move in the leftward direction, this block A, and whereas block B will try to move in the downward direction. So based on that, the frictional resistances shall be like this, correct? Right? So based on this, we will draw the free body diagram. Okay. We have now understood the direction of the motion of these blocks, and now we will see the free body diagram which we will be using. Okay. Over here, one thing you should note that the self weight of this bar or strut, it is given, huh? It is mentioned. So the strut is connected with the help of smooth pins, you can consider. And once we say that the connection is with respect to smooth pins, then we will expect two reaction forces at this point A as well as at point B. And what will be the direction? Horizontal and vertical. Okay. These reaction forces will be developed at point A. And since this strut is connecting with the block A and block B, equal and opposite reactions will be transferred on block A and block B as well. Right? From block A to the strut and from block B to the strut. Okay. So likewise, okay, this is point A, this is point, or rather point B, point A. Okay. This block has got self weight that has to be remembered. So since it has self weight, this is 200 Newton, which is given. Fine. Now, if you remember, we had discussed that whenever there is a pin connection, two forces will be developed. Okay. And if the rod, which is getting connected with the help of another rigid body, with the help of pin supports, if it has got some weight associated to it, which is non-zero weight, then you will expect horizontal and vertical reactions both. Okay. So let me assume the direction of reaction forces on this bar to be like this. Okay. And again, what I will say, I will consider, or in fact, I will assume, let me assume this to be like this. Tick. And I will consider the XY axis to be like this. This is true vertical and this is inclined horizontal with respect to this. Okay. So let me consider this to be, if this is point A, this is point B, this is your AX, this is AY, this is BY and BX. So AX and BX, these are actually inclined forces. So what you can do is, you can resolve this into components like this. You know this is 30 degree. This is given in the numerical. Okay? What you do? Equations of equilibrium, Fx equal to 0. So Ax cos 30 minus Bx cos 30 equal to 0. Over here, what do you observe? Ax equal to Bx. Okay? Because there is no other horizontal force associated to it. Second, summation of forces in y direction equal to 0. So how many forces? Ax sine 30 plus Ay plus By minus By, sorry, Bx sine 30 equal to 0. But from this equation, as you can see, Ax equal to Bx. So I can substitute this value over here. And what do I get? Ay plus By. One more thing, sorry. There is one more term of 200 Newton. So minus 200 equal to 0. So I will get this value. AY plus BY equal to 200. From here, if I want to calculate AY and BY, I need to take moment about, let's say, moment about point A equal to 0. So what will be the value? 200 into this perpendicular distance. Okay. And what is the length? There is no mention of length as such in this equation. So you can consider this to be capital L. This will be L by 2, L by 2. So 200 into L by 2, L by 2, cos 30. This will be clockwise. Then By, since it will create anti-clockwise rotation, By into L, again, cos of 30. One more term, that is Bx cos component. So this will be creating anti-clockwise moment minus Bx cos of 30. Okay. And what will be the perpendicular distance associated to it? Which will be into L sine 30. One more term, that is of Bx sine component, which will be rotating in the clockwise direction. So Bx sine 30 into L sine 30. Equate this to 0. Okay. From this equation, what we observe? This term, this will get eliminated. Okay, because this Bx, if you can say, it is passing through the point A as well. So that is verified. And therefore, from this equation, what do you get? By and L cos theta will get eliminated. By will be equal to 100 Newton. Since By is 100 Newton, Ay will be again 100 Newton. Okay. So this is how the AY and BY values can be evaluated. This is okay. However, AX and BX, they are still unknown parameters because we don't know, but they will be there. They will be there. Okay. AX equal to BX value. So I suppose you have understood this thing, right? Now, what we will do is we will be representing all these values on this strut because we have discussed this thing with respect to the strut only. So what we will do is we will consider for strut. So the directions were like this because both the values came out to be positive. AY and BY, both these terms, they came out to be 100 Newton, isn't it? 100 Newton. Now, for time being, let me consider the directions of AX and BX to be like this. AX and BX. And from the equation, it was observed that AX came out to be equal to BX. So this is the free body diagram as far as this strut is concerned. Fine. So equal and opposite, listen very carefully, equal and opposite forces, reaction forces should be transferred at these two locations, that is at point A and point B. Okay, so I will consider these two locations. Okay, equal and opposite का मतलब हुआ AX will be in this manner, whereas AY shall be in the opposite direction. Similarly, Bx and By. Okay, so this is Bx, this is By, this is Ax and Ay. This is Ax. Okay. Now we need to represent the frictional resistances as well. Okay, because unless and until we represent all the external forces, your free body diagram is not complete. Okay. This will be the normal reaction. This will be normal reaction, and this is, let's say, Na. This shall be how much it is? 0.25. No, under B it is given, whereas under A it is yet to be found out. So this is mu A times Na. Whereas over here this is 0.25 and the B. This is and the B. Is this okay? Okay. Yes. One more thing. The self weight. This is given as 400 Newton. This is 300 Newton. 300 Newton. So now what we will do is we will consider, since we have already found out the Ax and Ay values, now we will concentrate on this, that is the blocks. Block of 400 Newton and block of 300 Newton. That is, let us consider free body diagrams for A and B. Fine. So let me say free body diagram of A. I will draw the bigger scale. So this is Ax, this is Ay, which is downward, any frictional resistance mu A times Na. This is 400, and this is Ax. Now over here, let me consider this axis system x and y. With respect to this, you can say this is an inclined force. Now it becomes easy for us to resolve it into components. What will be this angle? This angle. If this is Ax, if I extend this, okay. So from here it is 30 degree. Therefore, this will again be 30 degree, isn't it? Now, from this free body diagram of A, if I apply equations of equilibrium, minus Ax cos of 30, this is one x term, plus mu A Na, another x term. Any other x value? I don't find any other x value equating to 0. Summation of forces in y direction equal to 0. How many forces? Minus 400, minus 100, plus Na, and there is one more component which is minus Ax sine 30 equal to 0. So as you can see, there are three unknowns, and even if we take moment, it won't solve my purpose. So what I will do, I will shift to free body diagram for B, FBD of B. We'll draw its large scale. From here, this is Bx, then By, which is 100. Okay, this is normal reaction. This is your again frictional resistance. Over here it is actually given 0.25 times NB to NB. This is 300 Newton. Again, what we will do, we will consider this X and Y. And with respect to this X and Y axis, everything is inclined except for this 100 Newton and this 300 Newton. That's it. Okay. So ये है आपका BX. Okay. So this will be resolved, and you will agree this angle will be 30 degree, isn't it? So this is BX cos 30, BX sin 30. Then this. Now we need to be careful over here because you can see this inclination. This is 60 degree. Okay, and this normal reaction is with respect to the 60 degree inclination, right? So this will be 30 degree. So I will be writing this NB cos of 30, NB sin of 30. Similarly, this. Okay, so this will be N 0.25, 0.25 NB. This is cos 60, and this is 0.25 NB sin 60. So one has to be careful while noting down all the values. Now with respect to this, we take summation of force in the x direction equal to 0. How many forces do we observe? Bx cos 30 positive plus 0.25 and b cos 60. This is again positive minus NB cos 30. This is in the negative direction equal to 0. Summation of forces in y direction equal to 0. How many forces are there? Bx sin 30 positive plus 0.25 and B sin 60 plus NB sin 30 minus 300 minus 100 equal to 0. That means you can say minus 400 minus 300 minus 100, 400. Okay? So this is, let's say, this is equation 1, this is equation 2, equation 3 and 4. These are 4 equations. From this, I think you can get some value because over here you can see mu value is already given to you. Unknowns are only 2, Bx and Nb. So you can identify the Bx and Nb terms. And then you can substitute the values. Okay, you can substitute the values. Since Ax is equal to Bx, we have already found out. So since Ax will be equal to Bx, whatever Bx value you will be getting, that will be true for this equation. From here you will be getting Na, and once you get Na value, and Ax is known to you as Ax is equal to Bx. Okay. I am getting a Bx value to be 298.95 Newton. NB value 349.6. 349.64. And after substituting these values in this equation, I am getting UA 0.398. Okay? You can solve this, you can verify whatever I have solved over here and just check whether the values are correct. Okay? Is this okay? So I will stop over here. I will be evaluating your answer sheets within a day or two, and I will be posting whatever are the requirements. There may be a possibility that you people might have not solved some numerical or some explanation correctly. In that case, I will be writing what are the expectations, what else is to be written. Okay? So everything I will be posting it within a day or two, right? Is was there any kind of difficulty as far as the T1 was concerned? Anything which you found to be new, which was not taught? ऐसा कुछ दिखाई दिया आप लोगों को? Was it okay? Yes. Anyway, ठीक है. You people can leave. Thank you very much.